Hi everybody, it's Tom here from Ocular Eyewear, and we've got Sarah from Roberts Alexander Optometrists.
We're back.
Exactly, we're going to give you the summary of ICBO Day 3. We're not going to talk about dyslexia, we just thought that's a nice, catching topic that we thought we'd put out there.
Very mean. So can you just explain this?
Oh yes, this is my carriage badge. We're going to a fancy dress party tonight, the Wizard of Oz theme, and hopefully this will make me speak a bit more eloquently.
Wouldn't be hard. I mean, keep going.
Okay, so the first thing we want to talk about today was a lecture by Steen Alberg, and he was talking about just noticeable differences, and this is the concept that we use in vision therapy. He gave this talk about this quote from Albert Einstein. He said, "The purpose of the brain is to enable movement, and if we didn't have a brain, we wouldn't have a brain if we didn't move." So I thought that was quite an interesting take. He also talked about vision therapy. It's not about strength, it's about timing, speed and precision.
Loved that. I love that.
That's good.
Yeah.
And so one of the goals of vision therapy would be to maximise performance with minimal effort and energy, so making things automaticity.
Yep.
So what he was saying is that when it comes to designating an activity and thinking about just noticeable differences, is you want to be able to change, the amount that you want to change is detectable at least 50% of the time, and this is the level that you want to target your vision therapy to. And another little tip which he gave me, which I send pick up little random tips sometimes, was about when you're doing your physiological diplopia, which is an activity where you try and get people to be aware that you're seeing, when they're looking over there, they're seeing two of things. So when looking over that window over there, there's actually two of them, that you have some pencils. And rotate them vertically, and then you can, if you move your head from side to side. So when you're doing physiological optometry, all those optometrists out there, use pencils. Okay, so the next thing we talked about, or we'll listen to...
Oh no, can I go back? My turn.
Yeah, sure, go
I'm going to hold the microphone. So the thing I wanted to bring up is, he made a point about the fact that the reason we have a sensory system, like Tom said, it's for movement, but the sensory system is made for detecting change. And so the detection of change is essential before your body will do something. So when we're doing vision therapy, we're trying to train the brain in how to detect changes, how to notice these differences. And that comes back to, we're not doing vision therapy to strengthen anything, we're doing vision therapy to finely tune your awareness of change, your awareness of changes in time, in speed, and make you more precise.
It's not a muscle strengthening exercise, it's all about precision, isn't it?
Good. All right, you can keep going.
Okay, so the next lecture that I listened to, I'm not sure if you listened to it, was the use of neurotherapeutic lenses in traumatic brain injury by Charles Shidlowski. Yeah,
like
anyway.
Szczepanski.
Yeah, okay. All right.
Our Polish friends.
So a couple of things I took home from that was that 50 to 90% of people with acquired brain injury are going to have some sort of visual dysfunction. That's pretty huge.
Massive.
And so some of the things that they might not say they've got a vision dysfunction, but some of the things that might masquerade like a vision dysfunction would be, I don't like going to the mall, or I get headaches, I see two of things, things seem to move sometimes, I have poor concentration or attention, I lose my memory, like what's happening right now. I'm photophobic, or I have asthenopic or headachy type symptoms.
Really light sensitive patients, you have to do the consultation with the fluoro lights off because their eyes are just watering. You can't shine a ret in their eyes because their eyes just water. So yeah, they're really sensitive. Another
thing which he because he's a funny guy, he said the critical age for neuroplasticity equals, what do you reckon? Death. Yeah, so basically it means that you can do vision training anytime, any age, and you can make improvements.
Yeah.
He also talked about campimetry, so that's one of those, that's a test where you measure colour fields, and it was interesting because he talked about that as more of a concentration test as opposed to a visual field test, and lots of people that do syntonics do campimetry pretty regularly. Another concept which he mentioned was called focal binding. So this is when your visual stress increases, the neurological response is to constrict your visual field. Which I thought was quite interesting. And when you think about it, if you're stressed and you're reading and your visual field is really constricted, that could be a big problem because you might be scanning across a page and you can only see a couple of letters. That will make it quite difficult to read.
Getting back to what down. Exactly, it slows down how fast you can read. It makes it harder to comprehend what you're reading. So your enjoyment of reading will often go away.
Another thing he talked about was visual midline shift syndrome. So I'll say that again. Visual midline shift syndrome. Right, okay. So basically what that means is that if you had a acquired brain injury, then what you think is the middle of you is you might think that's the middle of you, but it's actually not. And there's a couple of ways that we can measure this. We can have like a wolf wand or something, which you move across slowly, and then when it gets to the middle, you ask the patient to say that's the middle. Another way that you could do it is with a gait analysis. So if you look at the patient walking, if they've got if they tend to move to one side or their head tilt to the side, then that might indicate a problem with visual midline shift syndrome. Some of the things that you might want to do for this would be therapeutic interventions such as tints, occlusions, and prisms.
Should we talk about tints?
In a minute, I'm getting to that, because you might notice that we've actually got a special type of microphone today. Okay, so he also talked about a model proposed by Deborah Zielinski. It's a Polish thing, I think. I don't know.
Shout out to our Polish friends. Represent.
Anyway, he was talking about the model of optometry, and how there's sort of like 3 different areas. You might have they've got the parvo system. This is all of the ganglion cells going to the brain. So you've got the parvo system, the magno system, and the kino system. And what I took from this is that the parvo system is obviously super important for making sure that you see things clearly. Magno system, the where is it, the ambient peripheral system, modulates movement, and then you have the cornea system, which is how you respond to colour. And so my sort of take from that is that, if you go and have an eye test and you're only sort of checking the parvo system, are you getting a third of an eye test?
Well said.
I know.
Well said. Send all your questions into Tom.
Yeah, exactly. All right, so you might notice that we're holding this flipper here, which happens to be an FL41 tint. And Charles was saying that you can actually get some benefits from patients from using this particular type of tint. Just so you want to have a bit of a look at what it's like that. Yeah. That's a bit less. That's the full one. Anyway, so I did a bit of Googling, and I've actually found a bit of literature which supports what he was saying, that the FL41 tint improves blink frequency and light sensitivity. It also helps patients with photophobia. And the really interesting thing about this is that this is all ophthalmology literature, which, I thought was quite interesting because... there's obviously a bit of controversy at the moment about prescribing tints for people. I just thought I'd point that out.
And we also want to thank...
Oh, yes, we want to thank CR Surfacing for letting us borrow this particular
Do
crop,
they know you've
which
borrowed it?
they don't actually know about yet, but I'm sure they'll be fine with it. CR Surfacing do a wonderful job for me, and I definitely suggest if you ever want these tints, the FL41s, then they're the ones to go and see. Okay, so Charles also talked about how you make assessments with like prisms. You talked about prescribing prisms, and he talked about that when he was doing probing with prisms, he would use a particular test called the Bowen Gradient test. So basically, it's a pattern glare a presentation that has pattern glare, and he would do a gait analysis and a posturograph, which basically means that you stand on this device and they tell you whether you're leaning forward or backwards and how accurately you're standing. Fortunately, you can get RX pads, which are like memory phones, which are much cheaper, which you could also do some similar analysis with as well. Another thing which was really interesting that he talked about was flicker perimetry instead of standard perimetry for people with acquired brain injury. And he said that this is much more likely to pick up problems, and I didn't know that. So that was
really interesting.
pretty good to hear.
Yeah.
He also talked about binasal occlusion and how basically when you put a binasal occluder on, it sort of forces people, it suppresses that central field, so it forces them to be more peripheral, and it can have rapid changes and improvements in their balance and visual comfort.
I think it just helps to slow down all of that parvo information that's coming into them, because often these people with the brain injury seem to be just so visually overwhelmed. As we said, they're light sensitive, they can only read in these tiny spots. So, binasals is my new favourite thing to do as well.
It's like amazing what a piece of sticky tape can do. Okay, so another lecture that we listened to was from Liz Watson. It was called Visualisation. And one of the things I took home from this is that goal setting in vision therapy is very important. And I think that I definitely agree with that. So basically, the patient themselves, whether that's a child or an adult who's doing the vision therapy, they're the ones that have to articulate the goal, and that's what you need to design your vision therapy based on. So for instance, as a parent, you might want your child to be able to maybe process information better and read better, but the child might be more interested in making sure that they can kick a soccer ball further and more accurately. So you've got to take that into consideration. So just a couple of examples of how to use visualization in vision therapy activity. So I want to talk to you about Brock string. So the example that Liz gave was Brock string for a tennis player. And so if you imagine you have to visualize yourself on a tennis court.
We have a child in the room. Keep your stuff together.
The beads on the string. So Brock string, just for those people who don't know, is just like basically a string with beads on it, and we hold it on your nose, and it gives you the ability to know that you're using both your eyes together. Yeah.
Beautiful.
So imagine that the beads are a ball. You could change your posture when you're looking with the string, so that would better represent what it would be like.
You're saying don't keep it on the midline.
Yeah, like
if you've got a
problem with your backhand, then you should be holding it like this, because that's how I hit a backhand anyway. So
your backhand's very good, I'm sure.
I don't know about that. Across the midline. Okay. So another one she talked about was letter tracking on the back. So when you've got, like one of the activities that we like to do in vision therapy is where you write a letter on somebody's back and you ask them what the letter is. And she mentioned that also is working on integration of the spinal gland reflex, which that was great. I like that.
Yeah, that's
really
right.
Good. And then the magical eraser activity, where you sort of think about a word and then you ask the child what the word would be if you dropped out a couple of letters. So they've actually got to visualise what the word looks like and then take out a couple of letters and say what it is. So that was a pretty cool activity.
That's great.
Okay, another talk we heard was from Carolyn Hurst. It was about neural integrators. And, as I said, I thought that was like some sort of cool young person's TV show or something. It sounded really good, so I went along and listened to that. And so I said, what is a neural integrator? So basically, it's a group of neurons that store short-term memories. So for example, if you want to look at a phone number and memorize what it is, and you're utilizing some neural integrators, and you've got to be able to remember it, obviously, before you actually press the button on the phone. So there's obviously also some ocular neural integrators which are really important to ensure accuracy of eye movements. And so she was basically saying that it's a bit of a cycle, really. So I was working on that sort of just notable differences, I suppose, again. So basically you need to have good cerebral control of learning and movement and timing, which then leads to, basically that depends on, should I say, a sensitivity of the accuracy of your ocular proprioception, so where your eye muscles are, and that obviously depends on the number or maturity of the little receptors in your eye muscles. And just skipping down there on my computer, and that obviously depends on the stimulation that you received when you were younger, and that obviously depends on the learning that you've gained from your from the primitive reflexes in your first year of life, and that obviously depends on the health of your cerebellum. So interestingly, she said that when we're actually assessing primitive reflexes, we're not actually assessing their presence, we're actually assessing the amount of learning that we've had to develop the postural reflexes to compensate for the primitive reflexes.
Yeah, so I don't want to repeat everything you just said. I'm not as intellectual as Tom, so I had to turn it into my words. And when she said that, so I kind of went, all right, so if a child is still presenting this, primitive reflex, this neonatal reflex, it means that, the reflex is there to teach them something. So if they're still presenting with it, it means that they haven't learned what they were supposed to learn from that reflex. Which I guess we kind of already know, but when she said it like that, I kind of went, that's a great way of explaining it. It was really good.
Came on.
Yeah.
Good.
I think for me, that talk was really interesting from a neurological perspective. And it's fair to say my neurology is not great, but it's an area that I find just so interesting and I wish I understood better. So this did kind of help. Because when I think of the cerebellum, she's talking about it in terms of it controls the learning of movement and the learning of timing. And in my head, I just think of it's my how-to center. It's the part that my body goes to when I go, how do I converge my eyes again? How do I move my eyes again? Yep. And we see a lot of people with brain fatigue and brain injury, and it's as though the cerebellum really gets affected in those cases. It's as though the brain forgets its how-to. So I found the lecture really interesting from that point of view.
Oh, it was great.
Yeah.
And then we had a lecture from Ed Howe, and I really enjoyed this lecture. I'm still trying to compute most of it. Basically, just to put it in perspective, Ed flashed this model on the screen, which we've obviously seen before because we have both.
Nerds.
Yeah, we both finished our. Yeah, so this is Ed's simplified model of the visual system.
Is that backwards?
And I really don't want to see the complicated one, because
it probably doesn't even matter if it's backwards for you. It's not actually any easier to understand if it's forwards.
Well, I think I understood it a little bit better this time after I've seen it a couple of times, but yeah, I don't want to ask him for the complicated one. So some of the take-homes that I got from Ed's lecture was that when you measure contour stereo, that's the fly one, that you're actually using both the parvo and the magnocellular pathways, whereas if you're doing randot stereo, which is like the other one, the shapes one,
and
you're actually more reliant on the parvocellular pathways, and this is why you might get patients that do really well in the contour and just bomb out on the randot. So that was pretty interesting. Now, Ed also did a bit of a speculation with respect to the reason why you see those illusions as well, and he was sort of talking about that, you know, obviously the parvo and the magnocellular processes occur at different speeds and times, and that could be part of the reason why we see those illusions that we referred to last time, that ones that, those ones. So it looks like the lines are curved, but they're actually not. So that's
just good. We've just done split screen. Look at that.
That's pretty cool, isn't it? And finally, the last section we heard about was with Vivid Vision and VR. And I just really want to ask you about your experiences with this.
Good. All right. Well, I would say it's still early days for us, and the evidence is still coming out, but clients love it, and we find we're having great success, especially with adults. So it's really, we're using it for adults who've got lazy eye and turned eye and have never experienced depth perception or 3D before, and they're addicted.
So just to clarify what this is basically a new paradigm of vision therapy, I suppose, where you wear these Oculus Rift headsets, and it presents different images to the different eye, and the whole idea is that you use a binocular system to put it back together, and they can modify the image from one eye to the other, the contrast, and also the angle that it's presented, so that you can try and stimulate binocular vision when you might not ordinarily have had that. So yeah, I mean, it sounds really exciting type stuff. I'm not sure if it runs on the board for me quite yet as far as improvements with
Tom's a bit more of a nerd than I am.
But I'm pretty excited about it.
It is. It's really good. And I think it's exciting to see that optometry is embracing technology, and that there are many more things that we can do with vision therapy and with vision now that we have access to this level of technology.
So if we haven't bored you already, I reckon we've had enough right now.
We need some more wine anyway.
Yeah, exactly.
It's time to go.
Cheers.
Cheers.
Enjoy your Saturday night.
Indeed.
We'll
be back
tomorrow. Yeah, thank you.
Cheers. Bye.